going on? Let's go. So, adding and subtracting like fractions. So, there is a definite difference between adding and subtracting fractions with the same denominator and adding and subtracting fractions with different denominators. There's a big difference. So today we're just focused on the denominator being the same. On Wednesday, we'll focus on the denominators being different. So, first thing is what makes like fractions? Like fractions have the same denominator. Like fractions have the same denominator. Now, I don't like the fact that they made all the denominators 6, because I don't like seeing the number 6 in a row like that. But if the denominators are all the same, those are like fractions. Like fractions can be added and subtracted. If the denominators are different, they're unlike fractions. Unlike fractions, you would need to force the denominators to be the same. So those you would need to attack by force, which we'll do on Wednesday. So today we're just focusing on adding and subtracting when the denominators are the same. That's our primary focus today. So as far as how do we do this? If the denominators are already the same, then we add or subtract the numerators, keep the denominator, and reduce. So if you have 2 over 9 plus 4 over 9, the denominator is the same. So you would do 2 plus 4, 6, and then you reduce. I'm showing you the right way because I'm going to show you in a second how most people get this wrong. So I'm showing you the right way first. Subtract it the same way. 11 over 12, 5 over 12. If the denominator is the same, subtract the numerators, and then reduce. If the denominator is the same, you only have to worry about the numerator. You only have to worry about the numerator. So, this is how most people get these type of problems wrong. So, I'm going to show you how most people get these problems wrong. 2 over 9 plus 4 over 9, they figure, oh, I'm adding. 2 plus 4 is 6, 9 plus 9 is 18. No. If the denominator is the same, you don't touch the denominator. If the denominator is the same, you don't touch it, you leave it. Same thing with subtracting. 11 over 12 minus 5 over 12. 11 minus 5 is 6. 12 minus 12 is 0. There's my answer. Now there's 2 things wrong with this. Number 1, that's not how you're supposed to do it. Number 2, you can't divide by 0. You can't divide by 0. So, if you've made those mistakes before, okay, you're human, you made the mistake. Don't do it no more. If you made the mistake before, okay, you're human. I can live with that. Any questions before we continue? Not saying you're hearing any. So let's go on to adding. All right. So pause. All right. Questions on A or B? Anywhere where you experience difficulty on part A or part B? Which one? What did you do?
I had 3.5.
And you got what?
I got 12.
All right. So what's the problem?
Oh, wait. I reduced the book number by 4, but for some odd reason I was 15. That's why I got reduced. Never mind.
Always check your work. Check your work like a fine-tooth comb. Any questions on adding? So, don't be ashamed to admit it, own it, and then we work through it. Let's bring it back. Any questions, A or B? Just heard on our conference, minor mistakes, we fix it, we end up getting the problem exactly where it needs to be. So 11 minus 3, so 8 over 12. Remember, we always reduce. Always reduce. Always, always, always reduce. 16 minus 7 gives us 9 over 5. Anybody out there leave it as 9 over 5? Am I choosing to leave it that way? Okay, that's fine. 9 over 5 is reduced. Remember, it's not a requirement. It's not required to change it to a mixed number unless the problem asks you to. If it doesn't ask, then don't do it. But for those of you who did, there's the work that you should have done. Questions, adding or subtracting? Any questions, adding or subtracting? Alright, not seeing any, not hearing any. So, mixed numbers. So if we have mixed numbers, then change them to improper fractions. Just like when you are multiplying or dividing. If you have mixed numbers, change them to improper fractions. So for the problem that's listed there, instead of leaving it as 1 and 2 ninths and 4 and 5 ninths, we would change it to 11 over 9 and 41 over 9. And then we add them up. 7 and 1 sevenths, 3 and 5 sevenths. Change them to improper fractions. and then subtract. Now, there's a couple pros and cons to this. And these are the same things that I tell my students at Prairie State. And soon to be my students at South Suburban, so I done came up on another teaching gig. So now I'm teaching at 3 places. That's messy, and it cuts out borrowing. So subtraction, borrowing becomes a little messy when you deal with fractions. That gets cut out. The time is that numbers can get big sometimes, but we're all smart. We know how to multiply, know how to add. We can handle it. So, that being said, let's throw and do 2 more examples. We'll wrap this up today. So we do 1 adding, 1 subtracting. So first things first, looking at part A. 2 1/10, 3 3/10. Somebody run me those 2 fractions as improper fractions. Somebody run. So first, change them over. The denominators are the same, so we can go right ahead and add them up. So that's 10 and 54. Somebody check me on that. Absolutely. What do you want to divide by? Divide by 2.
So then 27 or 2705.
2705. That will work. What's the other way I could give this answer? So 2705, what's the other way that I could run this answer?
Is that next number?
Yeah. What is it?
5 over 5 is 15.
Reduce that 4/10. You're right. Just reduce it. So we have 5. What's that other fraction going to be? Reduce 4/10. There you go. There you go. Problem's over. So again, it's not hard. You just got to pay attention to what you're doing. All right. Let's take a look at one more. 4 3/15, 2 11/15. All right. So somebody run me the 2 improper fractions. So the denominators are the same, so I can go right ahead and subtract. So I got 22 over 0, so my answer is 0, and I'm good to go.
No.
What's wrong? 15 stays the same. So we got 22 over 15.
And then that's 1 and my head, hold on. 1 and 7, 1 and 7, 15, right?
There you go. That's what I'm talking about. All you gotta do is trust yourself. What's the worst thing that can happen? Or you just find out where you made the mistake and pick up from that point.
Do you always want the improper fraction, or do you want to like reduce all the time?
You talking about for the answer?
No answers.
I don't need two answers. I'm just showing both to just keep giving you the practice. You can leave it as an improper fraction as long as you reduce it. As long as it's reduced. Otherwise, I don't care. So, any questions, parts A or B? Now, if anything, we should be real good with changing mixed numbers to improper fractions with as much as we do it. Those are like easy getting points right there. So, just to wrap it up before we close it up, again, if the denominators are the same, we just add or subtract, and we're good to go. Doesn't matter if they're mixed numbers, change them to improper fractions, and then solve it as normal. So, there